Hello students, today I am shooting this video especially for class 10th standard. I have used the science textbook and I am moving straight into chapter 12, which is electricity. Now I am going to do numericals based on the NCERT textbook. Now first, when we talk about the numericals, we know some basic concepts, right? We know current is equal to charge divided by time. We know potential difference is equal to work done in moving a charge. And we also learnt V is equal to R into I, where R is the resistance which we can find out by V upon I. There is one more formula also you will come across. The number of charges on any body is equal to, always the charges on the body will be addition of electron or removal of electron, right? You add electrons or remove electrons. Protons do not come into the play at all. Why? Proton is inside the nucleus and we talk about free electrons which are in the outermost shell. So, charge on any body will be addition or removal, subtraction of electronic charge. Now, how many charges? N number of charges. So, this is a formula we should also know. Q is equal to plus or minus Ne. Number of N is number of charges, E is electronic charge. The charge of the electron is 1.6 into 10 power minus 19 Coulomb. You also know that unit of each one, this is ampere and this is volt, right? Resistance is ohm. Yes, you can check all my videos and you will find all these things have been taught. Now today I am going to take the numericals part. Okay, the first one is example 12.1, which is in page number 200. Page number 200. Okay, what does the question says? A current of 0.5 ampere, I is equal to 0.5 ampere, right, is drawn by a filament of an electric bulb for 10 minutes. Time is equal to 10 minutes. When it is in minutes, we need to convert it into seconds. So, multiply by 60, that is the SI unit. So, you have 600 seconds as the time. Now, find the amount of charge that flows through the circuit, right? Q is equal to how much? So, very simple. We know I is equal to Q upon T. So, Q is equal to I into T. It's very simple. So, Q is equal to I into T. I is given how much? 0.5 ampere into 600 seconds we have now taken. So, remove this, divide by 10. So, 0, 0 goes, that is 30, 300, 300. What is the unit of charge? That is Coulomb. So, the answer is 300 coulombs, right? So, this is the first problem. And I move on to the below one. I call it as the inbox question. They call it also, everybody they call it inbox question. In the inbox question, I go directly to the third question. So, let me erase the board now, right? Yes. Now, in this question, they are asking charge is given, right? And how many electrons are there in the particular charge? Okay, this is what is the question is. Calculate the number of electrons. Number of electrons is equal to how much, right? That constitute 1 coulomb of charge. Q is equal to 1 coulomb, right? N is equal to how much? Just now I told you we have a formula. Q is equal to plus R minus Ne, where E is the electronic charge, plus or minus, don't worry now. So from here I can say N is equal to Q upon E. Q is how much? 1 coulomb. What is the electronic charge? You should know the value, that is 1.6 into 10 power minus 19 coulomb. That is the charge of one electron. Okay, that is 1.6 into 10 power minus 19. So what I do, 1 by 1.6 multiply by 10 power, it goes up, it becomes 19. So I can do one thing, I can write it as 10 divided by 1.6 into 10 power 18. I have taken 1 0 from here, right? Now remove this, divide by 10, it will go up here. So this is going to be the 600 upon 16 is what we need to solve it, right? Now see here, 100 upon 16, okay, 6 times it will go, that is 96, then 4, it will not go, 0.0, 2 times it goes 32, 8, 80, right, and 5 times that is 80, answer is 0 here, result that is the remainder is 0. So the answer is 6.25 multiplied by 10 power 18. 10 power 18 what? You again come back to this point, N. Number of electrons. So that is number of electrons how much? In 1 coulomb you get 6.25. Even take it as 6. Okay, 10 power 18 means after 1, 18 zeros are there. Okay, in 1 coulomb is a very big unit. You should keep that in mind. Okay, so this is the second problem which I have solved it. Now, let me move on to the next question. Yeah. Okay, let me just move on to the next question. You have in the book 201 electric potential and potential difference, right? And then you come to page 202, example 12.2, example e.g. 12.2, that is in page number 202. Okay, see, now what is the question? How much work is done in moving a charge? How much work is done? W is equal to how much? In moving a charge, 2 coulomb. Q is equal to 2 coulomb, right? Across 2 points having a potential difference, V is equal to 12 volt. Very simple. Once you have taken the data, then you need to think of the formula. V is equal to W upon Q. V is equal to W upon Q. That is, potential is defined as the amount of work done in moving a charge from one point to another point. That is the potential difference. Okay. Now we wanted to find out the work done. So work done is equal to Q into V. W is equal to Q into V. Q is how much? 2 into V is how much? 12. So 2 12s are 24. Now what are you trying to calculate? Work done. Work done and energy. The unit is joule. The unit is joule. Keep that in mind. Okay. Now from here we move on to next question, that is the third question. How much energy is given? How much energy is given? In this case, instead of work done, they are saying energy. Energy is given. That is inbox question, right? For 1 coulomb charge, instead of 1 coulomb charge, and the battery voltage is 6 volts. Very simple. Now work done, potential difference is equal to W upon Q. W is equal to Q into V. So now you substitute here 1 and you substitute here 6 and the answer will be 6. Now what is going to be the unit? Work done and energy are two sides of the same coin. So the answer is again 6 joules only. The answer is 6 joule is the correct answer. Okay, so this is how you do the numerical. Physics numericals are very easy, right? But only thing is you should know how to take the data out. Yes. Now I want to tell you a method of doing numericals. Okay, how to make the numericals easy way we can do it, right? That is what I am going to now explain it to you. Okay, let me erase the board once again. Yeah, okay. See what I actually do. Let us try to do a problem, and with that I will explain. And the next concept is Ohm's law, and when you move on from the Ohm's law, you further move on. Experiment is there, fine, activity is there, factors. I am not going to do the problem on factors. I am going straight into exercises. Exercises in page number 221. Okay, page 221. Exercises. Okay, exercises, page 221. In page 221, I am going directly to the 8th problem in the exercise. 8th problem. See, we have to do according to graded method, you know, structure. We have to have the proper structure and we have to do. Now, very carefully you watch. When a 12-volt battery, I say take the data first out. Yeah, I always write like this in my method. Data. What is the given data? It is given when a battery of 12 volt, V is equal to 12 volt, okay, is connected across an unknown resistor. There is a current of 2.5 milliampere. 2.5 milliampere is the current. So remember, milli is there. These things you have to convert it. It is nothing but 2.5 into 10 power minus 3 ampere. This is the current. Now, this is the data. Once you have taken the data, let us read the question. Find the value of the resistance of the resistor. Okay. Now, it's very simple. You have to find the R value. Okay. For R value, what you do? Go to Ohm's law. Ohm's law says V is equal to R into I, and R is equal to V by I. That is, what is V value? That is 12 divided by what is I value? This is the value, converted value, 2.5 into 10 power minus 3. That is equal to 12 divided by 2.5 multiplied by 10 power minus 3 goes up 10 power 3. That is equal to 12 divided by 25. If I make, what will happen? Point will go and I will divide by 10 and it goes up 120 into 10 power 3. Now it's very simple. We have to just solve this 25. I think 4 times it will go 100. Remainder 20. Point, it will not go 0. Okay, that is 4 plus 4, 8 times it will go. Okay, 200. So remainder is 0. What is our answer? 4.8 into 10 power 3 ohms. You can read the answer like this. But what about 10 power 3? It is nothing but kilo. So 4.8 kilo ohms. You can write kilo ohms. Even if you don't convert, no problem. The board will give you the marks. Okay, let me now tell you. The next concept which we are going to talk about is in series and parallel. Yeah, you have to keep this in mind. I have done shorter video already on all these things. Okay, again for your reference, I am going to do selected problems now. Okay, and then we will take up problems from the textbook. Okay, so let us see. Okay, now we also know that resistors in series and resistors in parallel. Resistors in series, you say R1 plus R2 plus R3. Okay, and resistors in parallel, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So these are the two formulas. One is for series and another is for parallel. Okay, this is the parallel equation. Let us take a simple example and then I will do question from the textbook. Suppose I have a resistance three resistors, let us say like this. Now, one is let us say 1 ohm, another is 2 ohm, another is 3 ohm. Now, this is connected between the, let us say, the point A and point B. This is connected in between a potential difference of, let us say, 12 volt battery. A battery is collection of cells, right, which will give more potential difference. 12 volt I have connected. Okay, so now what will happen? What is the total resistance we have to calculate? R is equal to R1 plus R2 plus R3, because they are in series. That is equal to 1 plus 2 plus 3. That is how much? 6 ohms. This is resistance in series. Now we want to calculate what is the current flowing through. You know, in series the same current will flow through. Whatever the current is coming from here, the same current will flow through, right? So we know that Ohm's law, V is equal to R into I, and I is equal to V upon R. That is equal to V is how much here? 12 volt divided by total. This is called effective resistance or equivalent resistance. So 12 upon 6, that is equal to 2. What is here you are calculating? Current. So 2 ampere is the current flowing through in the circuit. 2 ampere. Now I take the same 3 resistors. Okay. So let me take resistor 1 here, right? And another resistor 2 here. And another resistor 3 here. Okay, they are going to be connected in parallel because one after the other. Here they are all in series and here they are all in parallel. What are all the values? 1 ohm, 2 ohm and 3 ohm. Fine. Now let us say this end is C and this end is D. So between these two ends I connect a potential difference V of VB, let us say again same 12 volt we will connect, no problem. Okay, now we need to calculate the effective resistance and also we have to calculate the current. But current, you have to remember, current only till here, because after that the current will branch out I1, I2 and I3. So this is one step. Next you have to do, first we will calculate the total current. Okay, let me erase this part now, okay, and take the data from there and solve the problem. Okay, see, what is the formula for resistors in parallel? Reciprocal. Okay, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Fine. That is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3. That is equal to common denominator. That means LCM 6. Okay, this is 6 plus 3 plus 2. Am I correct? Check it now carefully. 6 here and multiply by 6, 3 here, multiply by 6, 2. That is equal to 11 divided by 6. Yes, you all might make a mistake. 11 by 6. No. What is 11 by 6? That is 1 upon R, which implies R is equal to 6 by 11 ohm. Always remember, when you connect the resistors in parallel, the effective resistance will be less than the least. Less than the least. Now, which is the least one? 1. It is less than 1, you see, 6 upon 11. It cannot be 11 upon 6. Then it will come 1.8 or something like that. So, one of the conditions you should keep it in mind. You wanted to score the highest mark, right? In physics, you can score 100 out of 100. Yes, it's just like mathematics, but little bit logical thinking is needed, critical thinking is needed, analytical brain is needed. Okay, you should need to think little, and that will help you a lot in your future studies. Okay, when you come to 11th and 12th standard, or you want to appear for engineering examinations, or you want to appear for medical examination, IIT or NEET exam, these are all foundation. These are all foundation for you. Okay, now I have done this. Now again I go back, Ohm's law, V is equal to R into I is equal to V by R. V is how much? 12 we took, and the resistance has come to be 6 upon 11. So 6 upon 11, that is equal to 12 into 11 upon 6. Okay, it's very easy, cancelable 2. that is equal to 22 ampere. Oh my God, it's going to be something wrong. Let us check it now carefully. V upon R, 12, 6 upon 11, 11 goes up, 11 upon 6, 2 times 22. Now it is 22 ampere from the whole value, right? And it is going to branch out I1, I2 and I3, I1, I2 and I3. You will try that, how to calculate I1, I2, I3. Very simple. One I will do for you. I1 is equal to V upon R. We know that V is same. V is constant in parallel, right? Current is constant in series. So V upon R1, that is equal to 22 divided by, sorry, not 22, 12 volt divided by, what is R1 you calculated? R1 is 1, okay, 1, okay, that is equal to 12 ampere. So 12 ampere goes through the first one. How much will go through the second one? 2, okay. So what will do? R2, that is 2. How much this will be? 6. Now 6 ampere has come. Now what will be I3? Yes, it's a magic. 12 plus 6 is how much? 12 plus 6 is how much? 18. Right, and total is 22. 22 minus 18, how much? That is, I think 4 ampere. You try that. 6 plus 10 is 6 plus 4 is 10 plus 12 is 22. Please check it. Yeah, 22, 11, they are beautiful numbers. Because my birthday number is 11, 1, 1, magical number. Thank you.